My name's Michael Ward. I'm a part of Pearson Technology. We're all about learning. So we have been around for 172 years. We have 40,000 employees. And this is, if this, now what? Orchestrating an enterprise. What we're going to do is we're going to talk about how did we take Pearson, who is a really old company, has 70 hard data centers, and migrate to not only the cloud, but to Kubernetes. Again, I'm Michael Ward. I'm the principal architect at Pearson on a project called Bitesize. Bitesize is our platform as a service based entirely around Kubernetes. If you've never read my blog, go to devoperandi.com. We talk a lot about everything we're doing there. Our failures, our mistakes, our successes, everything is there. Feel free to ask questions, feel free to reach out, Twitter, email, whatever you want. All we're here to do today is to help show off what we're doing, as well as contribute back to the community in the ways that we feel we best can. So a little bit about me. This is my family, wife, Allison, and 3 girls. My wife's actually sitting back there in the back today, making me nervous. And I have 3 girls, 2 of which are twins. And my puppy, Zev. He's just 6 months old now. So naturally, I'm a family guy, but I dedicated a lot of time to work, and I'm very appreciative that they let me do this. All right, let's start out with some quotes. These are 2 of my favorites. One by Thomas Edison and one by Edwin Land. Anyone know Edwin Land? Anybody? Bueller? Edwin Land is the guy that started Polaroid. And I happen to like photography. And he learned how to polarize light, which is why the term Polaroid came along. But one of his key sayings was, don't undertake a project unless it's manifestly important and nearly impossible. I truly believe that that is important. And the reason for that is because really we all know that things aren't really impossible. It's just we haven't figured them out yet, right? All right, so Pearson, 172 years in business, 40,000 employees, 70 countries around the world. Our focus is on education, and really not just for educating students and people and communities that have money, but communities that don't have money. So oftentimes you'll see us go into countries or areas of the world that really have 0 money and 0 funding in order to provide proper education. And so that really makes our dynamic deployments very important, because we have to build applications that aren't necessarily always connected to the internet, like we think of when we think of cloud operations and cloud applications, right? Sometimes these companies or these students, these schools, they may only have internet access for a couple hours a day. So really important that we hone in on that, because that changes the whole game and the whole gambit about how we work and how we deploy systems. All right, so we've got 36,000 servers, 2,000 applications, 400 development teams. Each application, the ones that are microservices oriented, can have anywhere between 3 and 30 microservices per application stack. So when I talk about an application, I'm actually talking about an entire stack. So that 2,000 applications there are entire application stacks. When I came to Pearson, we had a 1-to-1 build ratio of development team to actual servers, i.e. Jenkins build pipelines. We're going to go into that a lot today, and hopefully you guys will be excited about what we're going to show off. So again, we're all about education, and we're all about open source. These are a couple of the projects that we've worked on or open source code for. We created an Auth-Z webhook, which was one of the first of its kind with Kubernetes. We're working hopefully to get that into contrib, or at least make sure you guys know about it and have availability to it. StackStorm is our event-driven automation platform. StackStorm itself is open source. We've added to it to work with the Kubernetes API. You're actually going to get to see that today. Pretty exciting. And Kubernetes test. Kubernetes test is all about testing your infrastructure once it's come up. So how do you know when you deployed that sucker that it actually came up, is usable, available, and can be counted on to move forward? So I spoke at KubeCon in EU, and I just wanted to give you a little bit of a status update. Not going to talk about business justification today, because we already did that. You can go look at the KubeCon video, check it out. So where are we at? There were a bunch of requirements that we had when we decided to build this platform as a service on Kubernetes. Geographically distributed, meaning we need to be able to be cloud agnostic, deploy anywhere, multi-region. We need to have cattle, Jenkins. Anybody tried to upgrade Jenkins before? Bueller? Yeah, pain in the ass. All right, and we want it to be fast. We want to have automated upgrades. So that's automated A/B deployments of our entire infrastructure. Obviously, you want to automate containers as well. Our objective is to automate our infrastructure upgrade process. Feedback loops. We want to provide clear communication across our teams. We want them to know, because in some of our application stacks, we've got maybe 150 microservices in an application or multiple across an umbrella stack. And we want to make sure that when someone else is having a problem hitting your API, that you know about it, right? Scalability, obviously we need to be able to scale. We need to be able to reduce costs, and we want to have automated deploys, not just upgrades. So far, we're seeing about a 45% cost reduction by moving to Kubernetes currently. And our sample size is relatively small, but currently it's about 45%. That does not include databases. We do not have, other than a couple persistent storage devices, we do not have databases in this equation. We're currently working very hard on that. Our last performance test, you can see under fast, it says 5 to 15% faster at a quarter of the resource consumption. What we found was we had these developers, and they would deploy in these massive AWS machines because they wanted the enhanced network, right? That they wanted a super fast network, and they could only get that if they built, like a C4X large. So when they moved to PaaS, they were actually able to reduce their application sites down to, a tenth of a CPU and 1 gig of RAM maybe, especially for Java machines. And they were actually faster than they were in their AWS environment. Pretty exciting stuff. I honestly was hoping it would be fast, but I wasn't sure that it actually would be. Jenkins is cattle. So Jenkins in our environment can go away at any given point in time. If one of you guys asks me to do it, I'll be glad to blow it away during this demonstration today. All right, standardization, same build process. We've got 400 freaking development teams. We want them to all have a consistent build process. So when they migrate between teams, they recognize the same sort of requirements. Compliance, security, visibility, ease of use. Less than 5% time management required. So one of our business requirements was that our developers had to spend 5% or less of their time with deployment pipelines into their environments. Quality testing, infrastructure, Kubernetes tests. I mentioned that earlier. We'll go into it more. Demo? I'm seeing nodded heads, but it's like 10 people going, yeah, come on. Give me some. All right. So if you guys have ever seen it before, this is the StackStorm interface. And all we're going to do is deploy a namespace into the environment. You're kidding.
No, we're not.
How do you not see that? That is not cool. It's in the same environment. How do we share multiple screens in this? No. Yeah, they can't see anything. Damn. Sorry?
Go to system preferences, go to display, change your arrangement.
All right, cool. Sorry about that. Thank you. Can you tell I'm nervous? All right, so let's go ahead. So what we're going to do is we're going to create a namespace, and we're going to add a repository to it, and that repository is going to be the initial repository that Jenkins will reach out to when we spin it up. So as you can see, we've created a namespace. We're going to add some labels to that namespace. We're going to save this repository off locally so that we can then go ahead and use that information for later. Now, in our environment, we have to be able to approve namespaces because we allow our developers to go out and create these namespaces on their own, but we don't want them to be able to just create 100 of them just because they feel like it. We want them to create a project which deploys multiple Kubernetes namespaces, dev, prod, stage, whatever, and then we go ahead and deploy Jenkins into one of those for them. So let's go ahead and set that up. All right, hopefully I approved the correct namespace. So now what we're going to do is we're going to take in Jenkins, meaning we're going to pull in a set of template files. We're going to deploy Jenkins into the namespace. We're going to delete the local files, and we're going to set up some quotas. So essentially, we don't really care much about, here, let me make this bigger. We don't care much about quotas, meaning particular to CPU and RAM. What we care about is making sure that in a multi-tenant platform that somebody can't deploy just crap tons of information, right? Or pods, excuse me. Whoops. All right. So as you can see with that automation, we went ahead and created some persistent volumes or some quotas around persistent volumes, pods, replication controllers, secrets, services, and notice that we only allow one resource quota per namespace. Now if I say get kubectl pods, namespace, cool. So now we've got Jenkins running. We haven't actually deployed anything through the command line. All we've done is click a couple buttons at this point. Now, I didn't tell you this earlier, but my objective for this is to actually be able to deploy this entire application in under 10 minutes. And hopefully, today, we'll be able to demonstrate that. All right, so what we're going to do is we're going to let that deploy, and then I'm going to go ahead and continue on with some of our information. We'll be able to check back in a few minutes on whether or not everything deployed properly and if we actually have a website up and running. So what did we just do? Well, we did quite a bit, as it turns out. StackStorm, we hit the UI, we deployed a namespace through the Kubernetes API, we deployed Jenkins. Jenkins then connected back to this config repository for a set of what we call bite-sized configuration files. These configuration files are just YAML-based configuration that you can take advantage of, and it automatically gives you all the guidelines you need to deploy your application. Jenkins then reached out to our code repo where our site is living, our test repo, and then it's going to create a series of slaves. So we have a parallel build process, meaning Jenkins is not just one massive server deploying this stuff. Jenkins is actually going to spin off slaves and tell these slaves to do stuff for it, which is great. Then what it's going to do is deploy our site, and run a series of tests against it. And yeah, let's get into the details. Let's see some code. All right, but before we talk about code, let's look at the features of this deployment pipeline. So it's YAML-based configuration. We've got blue-green deploys in place. It's beta, still working through it. It's really fantastic because our developers don't have to worry about managing this stuff, right? You can set it to continuous or manual. Obviously, we want to get to a continuous deployment environment, but we do allow our developers to do this in a manual process so that they're able to test this or test out their deployment process, their testing process and whatnot before it allows them to set those gates until they're truly comfortable with a continuous deployment scenario. Common build tools are just dependencies. So Maven or Java, Node.js, building of those applications, it's just a build tool dependency to us. We allow our developers to specify how they want to build it out. We don't really care. Jenkins is cattle. We can deploy Jenkins. We can blow it away. It'll come right back up and continue on its business. We've got versioning, build once, run anywhere, which is popular of Docker. Docker image management. So it's key to know that our developers don't actually have to know how to deploy a Docker image. Our developers don't know how to deploy a Kubernetes configuration unless they get all excited about it and want to. All they have to do is configure through Jenkins. Our platform handles the rest for them. Pipeline as code. So that goes back to the YAML config data. Really, all of our developers are seeing is a few endpoints. They'll see console, because we use console and Vault from HashiCorp, and they'll see their own YAML configs inside of their Git repository. Mounting persistent volumes, branch support, meaning you don't just have to look at master, as well as parallel builds. All right, so kind of showed you this a little bit already. What we do is we initiate what's called a seed job, and the YAML config exists inside of that seed job to deploy our application config. All right, some code. So Jenkins, our configuration files, there's only 3 of them. Environments.bytesize, application.bytesize, and build.bytesize. Now I can pretty much guess you already know what these things are going to do, right? So application.bytesize, the YAML file, is basically going to specify everything that is needed in order to build an actual application. So if you need multiple components to build into one Docker image, this is where you do that. If you need to specify or want to specify versions, you can do that here. And then you can specify what type of runtime if you want. So base image, in this case, it's Node.js 4.2.3. Every project and how we kind of coagulate all these bite-sized files together is through the project name. So in this case, it's head console. And then we establish a runtime command here. And basically all that's saying is it's the same thing as a command within your, if you're going to run it inside of a Docker image. All we've done is abstracted it out for you. All right, so build.bytesize or build.yaml. Again, you notice we've got the same project name there. We're specifying OS Linux up here. In the future, we do plan to offer Windows containers if people want to use that. But we don't currently have that capability. We've just added that in there. And then you specify some core dependencies. These dependencies tell Jenkins everything it needs to have installed on itself in order to build these applications. So this is entirely flexible. Gem packages, Debian packages, you can reach out to your own specific repo for a build. It's very flexible in the way you do that. All you're doing is specifying the dependencies here, which is great because once it's set, it's forget. Jenkins, if it bombs, it comes back up, reads what it's supposed to have, and it keeps moving forward. We then specify our initial repository here. So that's the same repository that I put inside of StackStorm just a few minutes ago. And then we specify some build commands in shell. So we're saying, okay, we're going to run build.sh, we're going to run fpm, and our artifact is going to be a deb package. And then, of course, we can keep on doing this, continuing to add other pieces of code and additional applications. But all in all, that's really not that much code to be able to continuously deploy your application. It's important to note, once this is done, you really don't have to touch it again. We offer versioning as a capability, but versioning is not a requirement. We can do versioning for you as well. All right, so environments.bytesize. As you might guess, all the environments file is doing is saying, okay, I'm going to deploy to a test environment. I'm going to execute these actions. I'm going to deploy these containers. I'm going to deploy these tests inside of each given environment. So as you can see, we've got a concept called configuring service and ingress there. We're actually doing 3 things when, 6 lines of code. We're giving it a service name, i.e. a Kubernetes service name. We're telling it what port we're going to expose it on for each container. We're setting some environment variables, and we're giving it this URL. So if you didn't know, this automatically configures your ingress for you. So you don't have to do anything. You can add SSL equals true. You can do all kinds of stuff in here. This is just really a basic example. All right, so tests. Notice that we have this test window. What this is for is currently our tests only deploy out once an application has been built and deployed. So these are kind of end-to-end tests, if you will. We're currently working to get tests inside of each build for unit testing and things of that nature. All right, so I've been talking long enough. Let's see if it actually worked. Keeping in mind I do have caching problem. All right, so there's Jenkins. You guys saw I've been talking out throughout this entire time. Jenkins went through the build process. It ran a seed job, connected to the repo. We have a thing called service manage here. What that means is if you do benign changes, like you want to scale the number of replicas in your application, all you have to do is set it, and it doesn't do a complete redeploy. All it does is manages the services and scales it up for you. So we've then ran our docs app there at the very top, and what that does is that's saying, okay, these are the actions I need to perform to build this website. Then we went ahead and built the Docker image. We ran through the environments pipeline to determine which environments we're going to deploy to. In this case, we're only deploying to production. Then you see something called doc site tests. Those are the tests that we wanted to run against the website to make sure it was up and running, right? All right, so let's look at those tests real quick. Now, this is obviously a very, very simple example, but we just wanted to make sure that it's not going to 404 out on us when it runs. We're saying, is it good? If no, exit 1. That's another thing that's important about our build pipeline. In order to fail a given build within the process, all you have to do is exit something other than 0, right? All right. Voila, built entire website from scratch. Let's see if it actually did it in 10 minutes or less. 9 minutes and 6 seconds. Not too bad, right? From scratch. Come on, give us some credit. This is a demo, of which I usually fail at. It's a couscous website. Yes, we can go into that in a few minutes. We'll get there. No worries. All right. No. We're going to deploy some databases, though. How's that? All right. So the database or the website works. That's awesome. So should we add a database? Anybody want to know how difficult that is? It's 3 lines of code to us. 3 lines of code. So let's exit from that. Let's kick this sucker off. Let's do Mongo. How about Mongo? Does that sound good? Oh, come on. All right. Now, I mentioned earlier that there are certain jobs that we don't actually move through the entire build pipeline for, right? I mentioned that in certain circumstances, all we do is execute service manage, which in our case runs every minute. So it'll check against our repositories, make sure nothing's changed. If something has changed, it'll execute that. I also mentioned that we don't deploy databases inside of Kubernetes yet. We do have some statically or clustered technologies inside of Kubernetes. Consul is an example, Vault is an example, Elasticsearch is an example. But those are all global services that we manage in a slightly different way. This is only for our applications or for our development teams that are actively deploying applications. All right. Please work. Might have to give it another minute. We'll see. Ha! Mean. I might kick that sucker off. Yeah. I think that I committed the code back just a little too late. As a matter of fact, screw it. Let's add a MySQL database to it as well. Now, to our developers actually don't care what type of database what database they get. They don't care if their databases are deployed inside of virtual machines, if they're AWS RDS, if they're Elasticsearch in AWS, or if they're an Elasticsearch cluster deployed on virtual machines. They don't care. They don't have to know about that. It's all abstracted for them. All they have to do is say, I need MySQL 5.6. and be good to go. Don't fail me now. Oh, breaking my heart. Did I deploy to Southeast? It's entirely possible. Oh, shit. That's actually what I did. Damn it. Hold on one second. My bad. It generally helps if the service launching this stuff is actually running. My bad. Told you, all the brains in here. You guys are making me nervous. All right. Let's see if it actually ran. Okay. No instances found. Hey, there we go. All right, Mongo databases are launching. Notice that this is 4 servers, right? We can expand that out as large as we want, as small as we want. It's all entirely dynamic to our customers. What's really, really cool about this is our customers don't have to know where these databases exist. They don't have to know the username and password. They don't have to know anything. All they need to know is the environment variables that are stuck in their containers at runtime in order to access a given database. That's pretty exciting because now, although I disagree this from a technical direction because I have a database background, I've heard a lot of people say, this is database as a service. No, it's really not. We're not providing a lot of the configuration values in here currently. We're not providing a lot of things that would really truly equate to a database as a service, but it's pretty kick-ass functionality. So let's go ahead and let's go over the RDS database, right? Let's see if that sucker spun up.
Mind if I ask a question?
Yes, shoot.
So you launched EC2 instances.
Break. Hey, we got an RDS instance with 3 lines of code.
Yeah, cool. Sorry.
Go ahead, Chris.
With the tool, are you able to, as an administrator, select whether it's going to go in Kubernetes cluster or EC2 or RDS?
Yes, absolutely. So within the Jenkins build pipeline, you can specify whether or not you want to run databases as containers, or if you want to run them as virtual machines. In MySQL's case, it's just RDS at the moment, but it's just a matter of you having a container image that'll build these databases for you. At the current, we basically build and develop this based off our current team's demand, and so we work from that standpoint. But we got a Mongo cluster, we got an RDS cluster, we got a full application stack in 15 minutes maybe? That's not too shabby. So let's get back to the Prezzo and let's see how it works. All right, so what we did here was, you can see at the top left-hand corner, Mongo, KubeMongo version 2.6. Jenkins picked that up, called out to the API, created a third-party resource. Everybody know what a third-party resource is? I hope so. You're in the advanced class right now. All right, so kicks out a third-party resource, which is just an API JSON hook, right? StackStorm then picked that up, called out to the AWS API, deployed the database with username and password, and then populated that data into Console and Vault. Now, why? Because we don't want our users to have to worry about where that data exists, how it exists, what it is. We just want them to be able to consume it as an environment variable inside their structure. All right, so let's go ahead and look at Console real quick. So this is our Console cluster inside of our sandbox running inside of Singapore. Come on, internet connection. All right, and let's look at some key values. Uh-oh. All right, so as you can see, when StackStorm executes against a third-party resource, it also, we execute some CloudFormation type templates, and we went ahead and populated the instance IPs of the Mongo cluster into Console so that the applications can consume that data at runtime through environment variables. So again, they don't have to care what they actually are. All they have to know is what the environment variable is in order to access it. Not bad. I'm not going to show you Vault because it's a little sensitive, but just keep in mind that that data is automatically populated into Console and Vault at runtime. Man, we are short on time. So, is this open source? No, it's not. Sorry. I gave you this entire presentation to show you that it's not open source. Should we make it open source? Is this something of value? Do you give a shit?
Did you actually not make it a public repo?
It is not currently a public repo. All right. Should we actually do this? Technology. Jesus. I know, right? And it's not even showing up in the list. That's jacked. You're so smart, sir. All right, we're officially open source. Now, I should make note here. As you guys saw in the demo today, we're utilizing StackStorm. You can also go to the Pearson Technology GitHub page, and you can see and utilize all of our tools, all of our event-driven automation in StackStorm to combine with some of your third-party resources in order to do a lot of the same things you've seen today. It's also of note, we're only in AWS at the moment. Okay, we are working to be able to go to Azure, to Rackspace, to wherever the hell we want. We've already done POCs into OpenStack to make all this work. So that's it for that, but I wanted to make sure that we covered a couple more things. What would that be? Kubernetes tests. I talked about Kubernetes tests a little bit earlier, and I just want you to know that that is also open source, available for you to consume. There's already people taking advantage of this, even hopefully contributing back. And then let's talk about our webhook. So what we do with our Kubernetes tests is we actually run Travis CI to kick off a build on every PR for our, we run Terraform and Ansible for building our entire infrastructure. What's really cool about this is we actually deploy two different platforms, PaaS A and PaaS B. Then we use B to test PaaS A. So all of our tests are built into containers. Well, not all of them, but most of them are built into containers. And we have, this also allows for A/B deployments of our entire infrastructure. As you might have noted earlier, didn't have a big pretty green checkbox. We're currently working to make sure it's fully automated. But this is how we do testing of our infrastructure. We deployed, I think, 3 to 6 times in the last 2 weeks, the entire infrastructure. What we do is we migrate applications from A to B after this testing is done and we've verified that our deployment is ready. Auth0 webhook. So as far as I know, we're one of the first teams to actually create a webhook besides the standard Kubernetes RBAC webhook. It offers HCL level compatibility and configuration. You can treat service accounts and users the same, and it's pretty cool. So feel free to go check it out. That is also open source. And here's the team. So you'll notice that we have some Cloud Ops guys in there, Scrum Master. Really, up until recently, we only had 5 engineers to do all of this. We've been working on this for about a year now. We're in production in 2 different regions at the moment. So we have 3 minutes left, and I've cut you guys off. I want to make sure that you guys have questions and can ask some questions. On the slide deck, you can see I've got links here for all the different things we've contributed back, including our Vault SSL integration by Martin Devlin. Questions? Sir?
I saw mention of versioning being supported.
Yes, sir.
Can you describe what versioning means in your infrastructure?
Yeah, so when we're talking about versioning of each individual application component. And so it basically allows you to go, minor or major versions, and that is recorded as a part of the metadata framework in the Kubernetes API. That way we can then pull in all that data, governance metrics and that sort of thing, so that you can, so that our business units can see what's deployed at any given point in time. Yep. Anything else? Sir? Console? Okay. We run console in containers, yeah. We cluster it via the Kubernetes API. We've got a custom little Python script that'll reach out to the Kubernetes API. It says, okay, once I have 9 nodes available, grabs all the IPs back, and then clusters itself up. So yeah, you have to make sure that you bring down the containers in a, other than just crashing them and allowing them to time out. Kubernetes allows you to actually decommission containers and go through that shutdown process. Yep. Another big problem around console is that it has an 8-hour time limit on crashing nodes. So, yeah.
It looked like it was a Jenkins job that was pulling the SCM and deploying new things.
Yep.
Is that Jenkins running in the same Kubernetes or AWS deployment that
Yep.
is affecting, or is it
Yep.
affecting different?
So Jenkins has the ability to manage multiple environments. So the question for everybody was, is that Jenkins running inside the environment? The answer is yes. It deploys into a namespace, say /dev or /stage, whatever, and then it's able to manage multiple namespaces with the same standard naming convention. Yep. Yeah.
Are you multi-tenancy with Jenkins, or does each team get their own kind of configuration?
Each team gets their own container that configures itself. Yep.
You guys supporting GitHub Enterprise yet?
Supporting GitHub Enterprise.
You're testing out of GitHub.
Yep.
Have you guys banged on private GitHub Enterprise yet?
No, we haven't. Nope. Sir? So we're doing all kinds of tests in Kubernetes tests to make sure, for example, as a part of our base deploy, we deploy an Elasticsearch cluster consisting of 3 masters, 3 clients, and 3 data nodes. So we do tests to make sure that that came up, and then we run tests against the endpoint to make sure that it's available and running. And then we run more tests to make sure like Grafana, our Grafana front end is running. And we do that for the number of minions we expect, for the number of master Kubernetes nodes we expect. There's a whole litany of tests in there, from inspect to various things. Have a look at it, and even please add to it if you'd like to. Anything else? Sir?
When you define the external URL command that you showed off there that automatically sets up the ingress,
Yep.
I noticed you were using like an actual domain name. To my knowledge, ingress only defines IP. Are you using that through, is that going through?
No, that's running against kubedns. So we run the Nginx controller, ingress controller, and it automatically pulls from etcd that endpoint. So it's not IP based. Yep. Anything else? Going once? Going twice? All right. That's it, guys. Thank you very much. Appreciate your time.